Welcome to day 16, the grand finale. You have built a fully automated, event-driven, observable microservices architecture. But what happens when your app grows and suddenly 100,000 users hit your user service at the exact same second? If you have one autopod running, their CPUs will max out, the server will choke, and your app will crash. Today, we shall unleash the true power of Kubernetes, which is scaling and load balancing. We are going to take our tiny application and duplicate it into an army of microservices instantly. Let's look at our cluster. If we can run kubectl get pods, we shall see exactly two instances of our user service running. So let me expand this and pull up the terminal, clear it, so we can see what we want to do. So I'll say kubectl get pods. Okay, so you see we have two instances of our user service running. For local development, this is of course fine, but in production, two pods cannot handle a massive viral traffic spike. We need to scale and we need to do it fast. In the old days of monolith, scaling meant buying a bigger, more expensive server. In Kubernetes, we scale horizontally. We just stamp out more identical pods. We can do this permanently by changing the replicas number in our user api.yaml file. But during a live traffic emergency, we can scale imperatively straight from the terminal. Watch what I'm going to do. I'm going to tell Kubernetes to scale the user service deployment to 10 replicas. Okay. And I'll hit enter and immediately run kubectl get pods. So let's clear the terminal and then run kubectl scale. So scale is a keyword. Scale is a keyword. Space deployment space. What do we want to scale? The user service. So user service is the deployment we want to scale using kubectl. Then space, mention the number of replicas, minus replicas. Replicas like that equals to 10. Then I'll quickly say no objects passed to scale. Deployment.apps user service not found. Oh, sorry. If I do kubectl get deployments, okay, you see we have the actual name. It's called user service deployment. I think user service is the name of the pod. Sorry. So I'll clear the terminal and I'll rerun the other command. But this time, instead of saying user service, which is wrong, I'll say user service deployment space, then minus replicas equals to 10. Then hit enter and say kubectl get pods minus w to watch. Okay, so you can see, wow, that was fast. We actually created in a very short time and they are running. So I'll clean this up and say kubectl get pods. Look at that. Those are 10 pods running. We can count using this fancy Linux command. Okay. And you see we have 11 because of how we set up. Now, if I say kubectl get pods, not pods, but get deployments. Okay, there we are. We have 10 available deployments. This is awesome. In less than 2 seconds, Kubernetes saw that we only had 2 pods and realized we demanded 10, and instantly spun up 8 brand new instances of our FastAPI app. But how do the users actually reach them? Do we have to give the front-end developer 10 different IP addresses? No. Remember the Kubernetes service we built, I think in day 14? It acts as a built-in load balancer. Your users only hit one single URL. So the Kubernetes service catches that request, looks at all the 10 pods, and performs a round-robin algorithm, and the traffic is perfectly shared between them. So no single pod gets overwhelmed. Let's try to make this permanent so that it survives a reboot. I will go to the K8s directory and then look for the replicas setting. Where is that setting? I want to change the 2 to 10. Okay, it's right here. So I'll change this to 10. And after that, go back to our terminal, clear the terminal, and then we can attempt to scale down. Okay, we can attempt to scale down. So assuming that the viral spike is now over, users have gone to sleep, now we have 10 pods running, and it is just burning money on our cloud infrastructure bill. So we can scale down just as easily as we scaled up. We can change our replicas back to 2, apply the file, and Kubernetes instantly terminates the 8 unneeded pods and gracefully draining their connections fast. But we can also do it in the terminal. So I can use kubectl and say apply -f, okay, K8, was it K, lowercase or uppercase? I think it's lowercase. K8 /user-api.yaml. As simple as that. And we shall have everything scaled back to 2 in case we have the file back to 2. But let's do it, okay? Let me go to, I wanted to apply the 10, but it's okay. You've seen that you can use the apply command to apply this 10 or use the scale command. Let me put it back to 2, save, and then come here. What's this? Then hit enter. Since the path does not exist. All right, let me get out of this directory. Say kubectl apply -f k8 user api.yaml. Okay, so yeah, deployment configured. If I clear and say kubectl get deployments, you see we have only 2 deployments. If I say kubectl get pods, there we are with only 2 pods. And there you have it. You have just survived a massive traffic spike with 0 downtime, but also been able to take it down back to only 2 pods. And yeah, let's just see what you've accomplished over the past 16 days. Number 1, you started with a basic Python script. You broke it into microservices using FastAPI and UV. You taught these services to talk synchronously using gRPC and asynchronously using RabbitMQ. You secured them with GWTs behind a traffic API gateway. You gained X-ray vision using Open Telemetry and Grafana. And finally, you automated and scaled the entire system using GitHub Actions and Kubernetes. You don't just know Python anymore. You know how to build a modern production-grade distributed systems. Thank you for watching this 16-part journey. Subscribe to the channel. Let me know how you enjoyed this, what you learned. In the next time we meet, who knows what will come up. But yeah, let me know what you learned in the comments, and I'll see you in the next series, live stream, or a video. And get better every day.